Hello, I'm Carl Rowland with Sherline Products. In this video, this is going to be an extension of our G96 video for constant surface speed. So in this video, we're taking one of our 3082, which is a end mill holder blank that's 2 inches long. And what we're going to do is turn it down and then spot drill and ream to turn this into a 3/32 jeweler burr holder. Okay, so the first program we're set up, we have our turning tool. We're just going to put this guy in here and you can actually see it turning material, and you'll see that the RPMs increase as each diameter gets smaller as it's working to turn the taper on this part. Okay, so I'll wipe this off, thread it on, make sure it's on good and tight. Okay, all right, now we're going to call up our program. Yeah. And you can see the shape of our part and the cutter path. What it's going to do is it's going to rough it out with my 80 degree, and then it's going to finish with my 55 degree boring bar on the back side. So I have a front side tool and a back side tool. The 80 degree is better designed for roughing material off. The 55 is better designed for doing finish work. So right now we've got it loaded. We go to program, hit rewind, and I'm going to single block into the part. So we're going to start hitting cycle start. Okay, and because it's G96, you've already heard the RPMs drop off from about 689 right now. Okay, so now I'm going to take it off single block and we'll just let it cut and you can watch it cut. Ready? Cycle start. Okay, the first pass is just a skim cut because I told her the diameter was larger than it actually is. The next pass is going to be a full depth 25 thousandths deep cut. So one thing you can do is you've got G code, which is on now, you have override. As it starts to make the next cut, if it looks like it's too aggressive, or if I want to be safe, I can slow my feed rate down. And if it looks like it's okay, I can speed it back up. Hit reset for 100%. So we're in an RPM range, we're at right about almost 1600 right now, at a diameter of 880. And now we're at a diameter of 830 and an RPM of 1720. Right now we have blue chips coming off, which means the RPM's a little higher than they should be. But the insert's doing fine, and we're not using any cutting oil. Right now we're just under 1/2 inch and we're at 2560. All right, so right now it's going to come in with the finish tool, my 55 boring bar, and do the finish pass on the back side. It won't change the override on the spindle speed because it's in G96. So that was a little bit of chatter on the nose because of the RPMs, but the rest of this is looking really nice, so we'll just let it go. So we're at 28 right now, and it's slowing down a little bit as we get to the outer diameter. 24. There you have it. Nice taper finish. So the next section of the video, we'll take this tooling off and we'll go center drill, drill, and ream for the 3/32 hole in the nose. In this video, we're doing the last stage of our 2078 jeweler burr holder. So in the first part of the video, we turned the taper. Then out in the shop, we drilled our Tommy bar hole and drilled and tapped the 540 set screw holes all the way through. So I've taken all the tooling off. I've mounted our 5935 5/8 gang tool holder, and I put in 3 of our 2081 WW collet holders, which have a 5/8 shank that go along very well with the gang tool post here. Our WW collets range from 0.3 millimeter to 8 millimeter. So you can find a WW collet size for anything within that range. So what I've done right now, first I indicated in the tool post to make sure it's square. It's got locating pins on the tool post, so it starts off pretty close to dead on when you mount it. And then you just run an indicator across the face to make sure that it's dead square to the center line of your headstock. Okay, so the first thing you want to do is indicate in your first tool. Okay, and there's a couple number of ways you can do this. I've already indicated this in. The tool post, the center line to center line distance on each of these pockets is 1.5 inches. All right, so once you've got your first tool indicated in and on center line, which this one is, then you go to your tooling page, and we used tools number 1, 2, 3 for the first operation, so I'm using 4, 5, and 6 for the center drill, and reamer. And on my MDI page, it's on tool number 4 right now. And so when I go to the tooling page, I double click on the center drill, number 3 center drill. And right now it's dead on center line. And what I would do is where it says test piece, I would leave the diameter at 0, just hit touch and save, which I've already done. And that puts this number in for that first tool. Once you've done that, you don't have to indicate in the rest of the tools. You already know what the distance is. So you go to your MDI page, okay, and it's 1.5 inches, which is 3 inches diameter, okay? So what you would do is an incremental move, which is G91. So G91, oh, got some extra stuff there. G91, G00, and I'm moving in the plus direction to go from tool number 4 to tool number 5. So it would be X 3.0 and enter. Okay, now my tool number 5 is on center line with the headstock and my part. Okay, so at this point I would go in and just go T5, M6, enter. It'll change it to tool number 5 up here. I would then go to my tooling page, double click on tool number 5, and again, the tool piece diameter, it's at center line, so that's 0. Then just hit touch and save, and then you do the same thing for the last tool. You're just doing a 3-inch diameter move to get from center line to center line, call up the tool, teach the test piece at 0 diameter, and now all of your x-axis numbers are set for 4, 5, and 6. Then what we would do is just come in and touch the tip of your tool to the front of the part. The front of the part is going to be Z0. So for the first one, I would go back to the MDI page, and I would go T4, M6, which changes to tool 4. Because it already knows the X numbers for each of the tools, I can now just go G90 for absolute, X0, and it moves tool number 4 to the X0 position. Then when we would go to the jog page just like we did in the previous video. You would jog it up, either use a piece of shim stock. For drills, you could probably just jog it in an incremental till it looks like it's touching the part and you're close enough. And then you would teach the Z for each of these tools. So these tools have already been set. I'm gonna go exit. This is going to be drilling 1.3 inches deep into the part, drilling and reaming. Okay, so when you have a small drill like this, or any drill, when you're going really deep with it, you want to have very short pecks. The biggest problem you come into is as you get deeper into the part with your pecking cycle, if you're taking too much material, it's going to fill up the entire flute length that's inside the part, and then your drill and the material that's in the flutes basically try to weld themselves into the part. So with short packs, you're not getting enough material to fill the flutes entirely, and every time it comes out, you just wipe off the chips, brush a little oil on, and it just continues to peck, and you don't overload your tools. So right now I'm on the F6 screen for loading program, and I've got my 2078 drill and ream short peck program. Gonna load it, and it's just a line because that's all we're doing. Okay, so it's going to come in, it's going to center drill it, and I'm using a center drill, not a spot drill. A center drill will find center, and then it's going to drill and ream. So I'm going to go to the MDI page, I hit rewind, and I hit start. Okay, at any time, if it sounds like the drill's struggling or if anything goes wrong, I can hit the feed hold and it'll stop the program right there. I fix my part, lubricate whatever I need to do, and then hit the cycle start button again. Okay, you'll notice that the drill is going straight down the center of the hole. It's not flexing off to one side or the other, so the alignment of the drill is dead on center. Same thing will happen with the reamer. And you can also see that the amount of material buildup on the flutes is not enough to fill the entire length of the drill. Okay, I also have this coming out to a retract distance of 200 thousandths in front of the part, which actually gives me enough time to brush off the chips and wipe some oil onto the drill tip. Okay, that's done. Now come over to the reamer. And I'm pecking this just because it's so deep. You could do it in one shot, but I'm going to be doing quite a few of these, so this program is set up for ease of operation. So there you have it. 3/32 hole, and this guy's ready to go.